new chapter, that is ultraviolet visible spectroscopy. There is another name of this, that is electronic spectroscopy. Because there is promotion of electron from ground state to higher states. Promotion of electrons from ground state to higher states. So this is known as electronic spectroscopy. What are the applications of UV spectroscopy? Or what are the uses? Applications or uses of UV spectroscopy. There are numerous applications of UV spectroscopy. By this technique, we can determine number of conjugative dienes. Number of conjugative dienes. It means that we can determine number of anes in conjugated system. Number of double bonds in conjugated system. Number of double bonds in conjugated system. Okay. Similarly, aromatic and anti-aromatic or aromatic and non-aromatic conjugated system can be differentiated by this technique. Aromatic and anti-aromatic or non-aromatic system can be differentiated by this technique. Third important thing is, by this technique, we can differentiate between alpha beta unsaturated carbonyl system with that of beta gamma unsaturated carbonyl system. This is alpha beta. If or this is, we can say here like this. This is alpha beta unsaturated carbonyl system. If we have like this is alpha beta gamma. This is beta gamma unsaturated carbonyl system. So by the technique of UV spectroscopy, we can differentiate this system from this system. Okay, this is the third important application of UV spectroscopy. Fourth important application is, by this technique, we can differentiate homoannular system to that of heteroannular system. If we have homoannular system, it means that both double bonds are present in single chain, that is homoannular. If we have a heteroannular, it means that two double bonds are present in two different rings. This is heteroannular system. So by this technique, we can differentiate homoannular system to that of heteroannular system. So these are little bit applications of UV spectroscopy. Now we will discuss what is the range of UV spectroscopy. Range of UV spectroscopy. The normal range of UV spectroscopy is from 200 to 800 nanometer or 200 to 800 millimicron, or we can say that 2000 to 8000 angstrom. You can write any one from these. So this is the normal range. Now you should learn one thing, that the electronic states, we know that the energy of electronic states is quantized. So we need particular energy which have a particular wavelength, so that it promotes an electron from ground state to higher state. Let these are two energy states. This is ground state and this is excited state. We need a particular energy which excites an electron from here to here. So energy states are quantized. We need quantized energy. If we don't have a quantized energy, then there is no electronic transition. We need quantized energy so that it promotes an electron from low energy state to higher energy state. Now coming to what are the different electrons which are promoted from ground state to higher states. We have three different types of electrons. Okay, are you getting my point? We have three different types of electrons which are promoted. One is sigma electrons. As you already know that the sigma bond is very strong. So to promote these electrons, we need strong energy. We need high energy. Like in that case, this is sigma. We have to promote this electron to higher state. We need strong bonds, and these electrons are present in saturated system. Second one is pi electrons. To promote these electrons, we need relatively less energy as compared to sigma electrons. Hence, promotion of pi electrons is relatively easy as compared to sigma electrons. We know that pi bonds are formed by side-wise overlapping. So to promote this electron, we need relatively less energy as compared to sigma electrons. And third important is non-bonding electrons that are present in saturated system with heteroatom like this. X can be oxygen, X can be nitrogen, X can be sulfur. To promote these electrons, we need relatively lesser energy as compared to pi, as compared to sigma electrons. So this was all about UV spectroscopy general introduction.